Okay, next we're going to calculate the pH of a buffer solution consisting of 0.2 molar ammonia and 0.3 molar ammonium chloride. Um, First off, a buffer typically consists of a conjugate acid and the conjugate base. Ammonia we have identified as a base. The conjugate acid of ammonia is ammonium ion NH4+. You notice that the base, or you notice that the other component in the buffer is ammonium chloride. The ammonium chloride is just going to supply the conjugate acid. Ammonium chloride as a salt will dissociate into NH4+ and chloride ion. The chloride ion is simply going to act as a spectator, and we can ignore it for the rest of this exercise. So one way that we can figure out the pH of a buffer is to use the Kb expression. And the Kb expression of any base has the base concentration in the denominator and the conjugate acid and hydroxide in the numerator. So in this case, the Kb of ammonia would be equal to the ammonium concentration times the hydroxide concentration divided by the ammonia. And we can look up this value from tabulated data, and its value is 1.8 times 10 to the negative 5. And so that's going to be equal to my ammonium concentration, which is given at 0.300 molar, and the hydroxide concentration, which we will solve for, because if we want to calculate the pH, if we can solve for hydroxide, we can take that to the pH. And then the ammonia concentration is going to be 0.200 molar. Doing the algebra to solve for this, we get 1.2 times 10 to the negative 5 is my hydroxide concentration. And that 1.2 times 10 to the negative 5 is a molarity. The pOH is defined as the negative log of the hydroxide ion concentration. And so we can take the pH of that, and taking the negative log of at 0.01, we get 4.92. Then the pH is going to be 14 minus the pOH, which would be 9.08. So that would be an example of a buffer calculation for a weak base and its conjugate acid.